Namaskar, welcome back. So last we stopped discussing where historical magnitude and all that, but we just talk about the dating part and all that. But details definitely we'll talk about that. What are the techniques we are going to use for uh, providing the age to the sedimentary units? Okay, and that is what we call dating technique. And as I mentioned in the previous lecture, that we have two robust techniques which are available in India. Is one is the AMS, accelerated mass spectroscopy, and where we usually use the carbon samples or the soil samples we use, okay, rich in organic matter, and plus the charcoal also. And if we get roots, that also we that will provide us the ages. Okay, how we do that is a matter of the research that we will also try to put in one of the lectures. Okay, now once we get the age of the units, we also try to look at that how much is the displacement in one event, and based on that there are empirical relations which talks about the magnitude as the respective magnitudes, that also we can talk. Okay, now magnitude of the historical earthquakes, that's how we are going to get actually. Okay, so based on the geological evidence and the amount of slip in single event, that is earthquake, we use that parameters, or we can say the geometrical parameters, to calculate the magnitude, okay, based on the empirical relations we get. We are also interested in knowing that what is the recurrence interval, how many, after how many years the similar type of earthquake is going to occur or reoccur in that area. So that is also important to have the proper seismic hazard assessment. Okay. So predicting of future earthquake, if possible, I would say that we still have a big question over here, because so far so we know that this is we are in that cycle. Okay, so once we have the understanding of the recurrence interval, we understand and we know that we are going to have a particular magnitude of earthquake, because that area has potential to trigger similar earthquake and had triggered similar earthquakes in past. Okay, so based on that, to some extent we can say that we can predict, but I would still say with some reservations that this is not yet achieved. Okay, and precise prediction, there are few examples which where the earthquakes were been successfully predicted and people were been saved. Okay, so there are techniques, more refined techniques, which need to be developed. People have been working on it, like scientific groups, to have this type of predictions, and hope that in future we will get success in this type of studies. Okay, but what we do is also extremely important, because that will tell you that how big earthquake had occurred in the past, and what is the potential of that area, and what is the amount of hazard posed by that region. Okay, so that is also more than enough to go for seismic hazard assessment. So further we will talk about the secondary effects. Okay, that what I was talking about, that we cannot say, and no one can say that, oh, I'm sitting for 500 400 kilometers away from Himalaya, earthquake is going to have to occur in Himalaya, so why should I bother? No, the secondary effect, and that is in particularly we talk about the liquefaction. So we will learn about the liquefaction. What is the process involved in liquefaction? Basically is a strong seismic shaking actually. Okay, so how big earthquake is, how large a larger amount of energy has been released by that particular earthquake in the past. Okay, and what were the effect? So sometime we try to dig into the historical records and try to see that, okay, fine, this earthquake, for example, earthquake which happened in 16th century, has affected or had affected the regions which are sitting in Indo-Gangetic plains. Okay. So that part also we try to understand, because and that's exactly what happened in the because of the Myanmar earthquake. Okay. There were side effects. Okay, like in particular area where the buildings where building got collapsed because of the secondary effect, and the most important process which will happen provided the site conditions are ideal, that is your liquefaction. Okay. So, how we are going to identify the liquefaction features, that also we will talk in this course actually. Then this course is not just going to help the geologist, but it is ultimately what we are doing is it has a very advanced and very, like I would say that it has an advanced application on that. Okay. So, this is an applied problem where civil engineers will also be helpful. Okay, if they understand this process, this course content and the course. Okay, they will also be benefited from this. Okay. And then, as I told in the previous slide, that we are going to talk about the techniques, dating techniques. Okay, what are those dating techniques? Other than that, we will also touch upon your geophysical mapping. Okay. So, there are various methods which have been used to identify the near surface deformation, to know that what sort of deformation or the features are present subsurface because of tectonic activities. So, uh, people have used like seismic reflection to go deeper, but shallower uh, deformation if you want to tap, then you are using the different techniques. Okay. So, one of the technique which we use is ground penetrating radar. So, that part also we will try to incorporate in this. Okay. And then it is important because there are, as I told, that there are landforms which mimic that they were formed because of the tectonic deformation. So, we will try to, and they were they got deformed because of the displacement on the faults or the deformation on the faults. So, we and those faults may be not seismogenic. Okay, seismogenic in the sense they may not produce earthquake. Okay, and we are interested in that what is the hazard from this earthquakes which if it take place. Okay. So, that sort of faults we will try to delineate, that is your what we call the seismogenic fault, which are having potential to trigger earthquake. Then we will also involve ourselves in structural analysis. This structural analysis is not the civil structures, but this is geological structures. Okay. Structural analysis of active faults and its implication on regional tectonics. Okay. So, that part also we will discuss in this. Then further, as I have mentioned about that, we are like if we have the map, a rough outline of India, okay, which starts from here, then it goes like, okay, and then it goes over here, then we have the northeast coming here, and then this goes. So, this portion is your the Kutch region, okay, and then we have this portion here, okay, like this. Okay. So, this region is active, and that is your Himalaya. Of course, this goes on the northeast also, this part. Okay. So, this is completely in that region, this is active. We have Kutch also, which is active, and then we have Andaman Islands over here, where you have the Sumatra sitting here actually. So, this is Sumatra, and this one whole area we have the Andaman Islands. Okay. Andaman and Nicobar Islands. So, we have threat from the tsunami. Okay. And I am using here paleotsunamis. That means we are trying to look at the signatures of the historical and prehistorical tsunamis. Okay. Why we are doing this? Again, we need to understand that the tsunami which was been triggered in 2004, was it the only tsunami which we experienced or this region experienced? The answer is no. We experienced many more tsunamis in the past. Okay. But we got triggered to have more understanding of this after we got affected. The effect was in this area, the effect was in Andaman area, not only in Andaman, but the regions which were adjoining the Indian Ocean. Okay. So, we have threat of this type of secondary effects, that is your tsunami from Andaman. Not only that, so it affected not only this region, but it also affected this part to some extent. Okay. Sri Lanka was part of it actually. Okay. But other than that, we are also having threat of tsunami to Gujarat and the coastal region of Maharashtra. And from where this tsunami will be generated is from this area, that is what we call Makran subduction zone. So, what is subduction? We will learn that part also. But right now what we are talking about, that tsunami part. So, we will also try to show you that how we have used the geological evidence and the signatures which are preserved in near coastal deposits, sediments, that talks about your the paleo tsunami or the ancient tsunami. So, that part also we will incorporate in this one. Okay. So, identification of paleo tsunamis and mega subduction zone earthquake. Now, why we have used this word actually, mega subduction zone earthquake? Because the largest earthquake so far recorded on this planet is 9.5 magnitude earthquake of 1960 Chilean earthquake. Okay. So, 9 magnitude earthquakes, very large earthquake, lot amount of energy has been released in this during this earthquake. Okay. And since this earthquake has occurred in the ocean side, it triggered tsunami, it caused tsunami. Okay. That is because of the mere disturbance of your water column. And why we are talking about the mega tsunami? Because we had 2004 Sumatra, Andaman earthquake, and plus we say this or we call this tsunami as a trans-oceanic tsunami, because it has gone across the Indian Ocean side. It was also received by other areas also. Okay. So, this is a transoceanic tsunami, wider area of the ocean, and the lands or the land area which was associated or which was in the fringes of this ocean was affected. Okay. So, very large area got affected, not only just the Indian subcontinent or Banda Aceh part, or we can say Sumatra, Thailand, okay, or Indonesian side. No, it affected a very large portion. And the magnitude here was almost 9.1 to 9.3. So, this is again falls under the category of the mega earthquakes, okay, where we are talking about 9 and above magnitude. So, this part we will try to understand, and then earthquake signatures which are preserved in the coastal and all that. Understanding of the land level change. Okay. We never had an understanding or any sort of a clue before 2004 that such mega earthquakes or mega subduction zone earthquakes can result into a land level change. Land level change in the coastal areas, okay, are very much important because they will affect your local environment. Local environment, it will affect the local environment. So, how this land level change can be identified? Everything is preserved in sediments. The signatures are preserved. So, that what we try to tap and we try to unearth those signatures from the studies which we carried out in Andaman. So, mostly in this course what we are going to talk is the examples, few examples, very few examples from abroad, that is from other countries where the this type of course, because the earthquake can occur anywhere, and that you will learn in few coming slides, okay, that which are the areas, regions which are prone to earthquakes and tsunamis, okay. So, but most of the examples or the case studies which we are going to talk in this course is from India. Okay. So that you know, for example, if you go for tourism somewhere and have to picnic, so you should know that how this Andaman got affected. It has a beautiful beaches, lot of good scenic views. Okay. Similarly goes to Himalayas. Okay. So with beauty you have the disadvantages also. Okay. So then we will also talk about the decoupling role of climate and tectonics, because everything is not governed by tectonics. There is also climate change. So when we are talking about the climate change, or particularly in the coastal areas, we are not going to talk much about the climate change in this region, but when we are going to talk about the tsunamis, we are going to talk about the coastal regions. There the portion of most of the area is been covered by ocean. So when climate change will definitely affect the ocean, because in the drier climates we can say that what we call glacial interglacial cycles. Okay, so glacial cycles we have sea level fall, interglacial cycles because they are warmer, then we have sea level rise because a lot of glacial ice melt is there or the snow melt is there. So, though you have more water that. Okay. So, how the landforms were got affected, were formed, were eroded, and if there is a tectonic land level change, that is land level change related to the tectonics, how we are going to differentiate that. So, we want to have a sort of a decoupling of this role between the climate and the tectonics. Okay. So, that also we will done. Understanding the effect of near field and far field. So, as what I put the outline of India, for example, again I am putting here. Now, so we have like okay, we have the Indian side here and the coast, and which is almost like more than 7,000 kilometers. We have the coast. Okay, so there is like, and then as I told that we have Andaman Islands here, and then we have the Indonesian side, which is Banda Aceh and all that. Okay, so this earthquake was been triggered over here 2004, and this earthquake continued to rupture for almost 1,300 kilometers. But then again, the point at which the maximum energy was been released was not in the Indian side. Okay, but it affected a larger area. Okay. So, we are also interested in that if there is an earthquake or the tsunami triggered in Indonesian side, what will be the effect to the Indian region. Okay. Now, it's other way around. Suppose we say that the earthquake is triggered here. Okay, then what will be the effect to the Indian side here as well as the Andaman side. Okay. So, that part is important when we are talking about the tsunami deposits, based on which we can also identify that whether this was the earthquake or the tsunami which was been triggered by the earthquake which occurred far away from the Indian side or it was closer to the Indian side. So, that part also we will try to talk in this course. Okay. The effect of the near field and far field tsunamis, how large it will be, and this cost not only in terms of course, one important part is that a lot of like people are staying along the coastal regions. Okay, they will also get affected, and also the nuclear power plants or the nuclear facilities which are operational and which are going to come in future. Okay, so that also part plays an important role. if we are having proper understanding of that, how high tsunami waves will be because of a particular earthquake, okay, and not only always in this area that we will have mega subduction zone earthquake, we will have also large magnitude earthquakes, okay. So, we have the potential, and this area has a potential to trigger large magnitude earthquakes as well as mega subduction zone earthquake, and the evidence or the lesson we learned was from 2004. So, what studies we have done in Andaman, based on that we will talk about, and we will also bring in the 2011 Tohoku earthquake signatures as well as 1960 Chilean earthquake, what happened during that part. Okay. So, this is itself a very interesting topic other than the other topics we are talking about. So, we will talk about this, okay, and what happened exactly in 2011 we will also talk, and as well as 2004. So, we have lot of books which you can refer, okay, for this course, and if required you can ask TAs to help you out in getting some sort of an articles which we have published. Of course, that will be important because we have discussed right from what we can say A to Z, okay, in that. Okay, so what methodology you will follow, what systematic steps you will follow to achieve this information and science part of from that. Okay, so that the TAs will help you in getting those articles and all that, but not books. Okay, probably books are copyright and we cannot share those things with you people. Okay, but journal articles, yes, we can to some extent we will share, and that will also help you in this course. So, there are many places, or we can say that on internet you will be able to look at this data which is available in free free domain. Okay. So, that you can download and you can learn, but these are the list of that. Okay. So, there are many journals which publish such type of research, and that will help you in that. We have also published in many journals which are been listed here. So, few particles or the papers will be supplied to you, or we will share that, and then you can download and go through. Okay. Now, coming to the distribution of the oceanic and continental plates, we will come to a detailed part of the plate tectonics, but if you look at the globe, okay, what you see that there are some land masses, and then there are different oceans or the ocean water which has covered that. We have, of course, we name those oceans, okay, like Atlantic Ocean, we say the Indian Ocean, okay, and then we also say a smaller portion in the west, it is Arabian Sea. Okay. So, we have this the major oceans, okay, and then we say the sea. Okay. So, we have the larger one is your Arabian Indian Ocean, okay, we are having, and then there is Atlantic Ocean here, and then Pacific Ocean here. So, if you spread out that, then you have the continents, and these are known as continents. Okay. So, land mass is known as continent, and then oceanic part is termed as that is the ocean, continental plates and oceanic plates. Okay. So, this is the part of the crust, or the topmost portion of the Earth's part. Okay. So, that is the crust you are having. Now, this crust is not stable. Okay, and they are broken in different fragments, and this fragments what we see now is your continents. So, you have here on your screen the North America, then you are having South America, then you have Africa, and then India is sitting a smaller one here at this portion here. Okay, and then you have the Australian side and all that. Okay. So, we have the continents and oceanic plates. Okay. Now, if we look at the other part here, then we have some sort of an darker colors which are been shown here. These are the topographies. Okay. How this topography got developed, that also will learn. Okay. And there are few places or the few continents which shows clearly that topography is very much aligned. Okay. Okay. So, you have the topography which is aligned here. Okay. You have topography which is aligned here, and these are Himalayas. Okay. So, you have this typical topographic indicators which talks about that this is the area which uh, formed because of the plate movements. Okay. So, if you compare the this plate boundaries, and but I'll stop here and then have a detailed discussion on this, the occurrence of the earthquakes and the lithospheric plates and all that we will talk in the next lecture. But in short, if you look at the symbols which are been given here, so we have like different symbols which talks about the subduction zones. So, what are the subduction zones? We will talk that part in greater details in the following lectures, but in next lecture we will just see look at that what is the distribution of earthquake and what are the hazards which we experience or the people experience on this planet in last couple of like in one decade. Okay, they will talk about that. So, till then, thank you so much. Namaskar.